The Kuiper Belt is a region outside most of the planets of the solar system.
There is a space outside of most of the planets in the solar system called the Kuiper Belt. The first object found in the Kuiper Belt was Pluto. It took about 60 years to find any more. The first time people saw something from the Kuiper Belt was on November 2nd, 2015. It used to be one of the most interesting pictures ever taken from space, but now that's changed. There has never been a clearer picture of the Kuiper Belt than the one that was just taken by the James Webb Telescope. There is a cold, donut-shaped area called the Kuiper Belt in the outer solar system. It is farther away from the Sun than Neptune, which is the 8th planet from the Sun. It was first interesting because of its shape, but then it became clear that this would be one of the most interesting things about Earth. The Kuiper Belt is named for the scientist Gerard Kuiper, whose work in the middle of the 20th century helped us understand the area beyond Pluto, but he wasn't the one who found it. Kuiper wrote a scientific paper in 1951 that made guesses about the possibility of things beyond Pluto. Kuiper's study was mostly about the idea that there might be objects beyond Pluto. It didn't go into specifics about what those objects would be like or how they would be arranged in this area, though. At first, Pluto was thought to be the main feature of the Kuiper Belt. However, it is now known that Neptune's orbit, not Pluto's, sets the inner edge of the belt. The gravitational pull of Neptune has been very important in shaping how the Kuiper Belt moves. Astronomers knew about Kuiper's groundbreaking ideas and contributions, even though his statements did not exactly match up with what was seen in the Kuiper Belt. After some time, the idea of the Kuiper Belt and the things beyond Pluto that are connected to it became linked to Gerard Kuiper. The first person to find Pluto was the scientist Clyde Tombaugh in 1930. He found it in what is now called the Kuiper Belt. At the time of its finding, astronomers didn't know much about the outer solar system and didn't think there would be so many icy worlds beyond Neptune. Most people thought that the solar system was made up of gas giants, hard planets in the middle, and Neptune, an icy giant, at the very edge. Scientists at the time thought Pluto was a single planet, even though its orbit was irregular and tilted. The second Kuiper Belt object wasn't found until 1992, 62 years after the first one. At this point, it was clear that Pluto was not a separate object, but rather a member of a larger group of objects in the outer solar system. After that, many KBOs were found, which proved the presence of the Kuiper Belt, a region beyond Neptune that is home to a variety of icy worlds. Pluto has a special place in the history of astronomy because it was first called the 9th planet, a name that stuck for many years. However, as we learned more about the Kuiper Belt and found more KBOs, especially ones bigger than Pluto, the International Astronomical Union changed the rules for what makes a body a planet in 2006. Pluto is now known as a dwarf planet, but it will always be remembered as one of the most important finds in our solar system. Without it, we would not have looked into the Kuiper Belt area as much as we do now. This one-of-a-kind place is thought to be an extension of our solar system because it is in the same spot in space and is affected by the Sun's gravity. The 8 major planets, plus Neptune, make up the inner solar system. The Kuiper Belt, on the other hand, goes all the way to the edge of the solar system. The outer solar system is different from the inner solar system. It is made up of icy objects like comets, asteroids, and dwarf planets. NASA says that the stuff in the Kuiper Belt is thought to be leftovers from the early solar system, which is about 4.6 billion years ago. It is thought to have kept conditions and materials from that time. It's like seeing history happen right now. Pluto and its moons are in this belt, along with Haumea, Makemake, and Eris, which are all dwarf planets. Besides that, the Kuiper Belt is also home to many different kinds of smaller icy things. This is a unique part of the solar system that we don't see very often. The Kuiper Belt is a lot bigger than the main belt of asteroids. The main asteroid belt is made up of mostly asteroids and other rocks that are in the space between Mars and Jupiter. It's not too thick and has a lot of small to medium-sized bodies in it. The Kuiper Belt, on the other hand, is a bigger and farther away area. This means that the Kuiper Belt has 20 to 100 times more mass than the asteroid belt. This means that the Kuiper Belt has a larger amount of matter, both in terms of the number of objects and their total weight. That's one reason why it was so surprising that it took so long to find out about this. But the fact that this place wasn't found right away doesn't mean it isn't important to the solar system. A lot of different heavenly bodies live there, such as the small planets Pluto, Haumea, Makemake, and Eris. Pluto was found by Clyde Tombaugh in 1930. It was once thought to be the 9th planet, but in 2006, the International Astronomical Union changed the standards for planets, which meant Pluto was now called a dwarf planet. With a diameter of about 2,377 kilometers, Pluto circles around the Sun with other large dwarf planets in the Kuiper Belt. Researchers and experts have also learned a lot more about this faraway area thanks to their work on Pluto. But this was only the beginning. Haumea was found in 2004 by a group led by Mike Brown. Its unique long shape, which may be caused by fast spin, adds to the variety of the Kuiper Belt. This dwarf planet, which is about 1,960 kilometers across, has taught us a lot about the interesting things about objects in the Kuiper Belt. Makemake is another thing that Mike Brown's team found in 2005. It has its own unique traits. Makemake is about 1,430 kilometers across and doesn't have a big atmosphere. However, its bright surface, which is made up of methane, ethane, and tholin, makes it one of the brightest objects in the Kuiper Belt. Eris was also found in 2005. It is a bit smaller than Pluto, but heavier, with a diameter of about 2,326 kilometers. Eris is an important part of the Kuiper Belt. Its finding led to a re-evaluation of what a planet is and helped us learn more about the variety of objects in the Kuiper Belt and how they move. Together, these dwarf planets tell us a lot about the Kuiper Belt's makeup, how it has changed over time, and its place in the past of the solar system. We would have no idea what the area was like without them. A lot of people around the world have mixed up the Kuiper Belt and the Oort cloud. What these people don't know is that the Kuiper Belt has more objects and is thought to be where short-period comets come from because their orbital periods are shorter. The Oort cloud, on the other hand, is even farther away and shaped like a sphere that covers the whole solar system. It's thought to go from about 2,000 AU to maybe 200,000 AU from the Sun. The Oort cloud is made up of icy objects that look a lot like dirty snowballs. It is thought to be where long-period comets with very elliptical paths that bring them closer to the Sun come from. The Kuiper Belt and the Oort cloud are both places and forms that are different from each other, but they are both full of icy bodies. Both are thought to be possible comet sources. Comets are celestial bodies made up of ice, dust, and volatile compounds. They become noticeable as they get closer to the Sun and get a glowing coma and a tail from the solar wind. It's okay to be confused sometimes, but it's still important to know the difference. Scientists are amazed by this place because the Kuiper Belt may only have a small amount of material left over from what it was like in the beginning. What we have now are literally only shards. The real thing has already gone away. Not by chance, though. The NICE model is a set of ideas that says that the orbits of the 4 largest planets in the solar system, Jupiter, Saturn, Uranus, and Neptune, might change in a number of important ways. It says that the big planets in the outer solar system haven't always been in the same circular paths. They instead went through a time of dynamic orbital development. The model says that when these big planets interacted with each other, their paths changed in big ways. It was thought that the Kuiper Belt held 7 to 10 times the mass of Earth. However, the NICE model says that a lot of that material may have been lost as the orbits of the big planets changed. Material in the Kuiper Belt may have been spread out, thrown out of the solar system, or moved to other areas because of the big planets' gravitational pull and changes in their orbits. The Kuiper Belt is slowly being worn away because of what's going on. Collisions between objects in the belt can break them up into smaller pieces, which can then collide with other objects in the belt. Different smaller objects might turn into comets at different times. The ones that don't turn into comets get crushed. The solar wind can carry the dust that is made when planets crash into each other out of the solar system. Scientists think that the Kuiper Belt's matter doesn't weigh more than 10% of Earth's mass altogether. It's not small, even though that makes it look small. It has been found that a lot of objects in the Kuiper Belt have moons. These moons are smaller objects that move around a bigger main object. This effect doesn't just happen on planets, it also happens on other things in the Kuiper Belt. Some KBOs are also binary systems, just like the moons. Two objects in a binary system orbit around a shared center of mass, which is also called their barycenter. The two objects are about the same size or mass. There are different kinds of orbital properties that these binary pairs can have. Some of these things touch, making a form that looks like a peanut. There is physical touch between the two parts in this arrangement, which is called a contact binary. The gravity forces that pull them together give them this unique shape. But people didn't always know this. It took a lot of work from NASA. Pioneer 10 was one of the first to get close to it. Pioneer 10, which was launched by NASA on March 2, 1972, was a revolutionary spaceship made to study Jupiter and the area around it. Pioneer 10 was the first spaceship to travel through the asteroid belt. It was equipped with scientific tools to study Jupiter's atmosphere, magnetic field, and radiation belts. Pioneer 10 was the first spaceship to go through the belt of asteroids and look directly at the gas giant. Pioneer 10 made another important historical event when it became the first spaceship to enter the Kuiper Belt in 1983. Even though Pioneer 10 went into this area, it didn't go to any icy worlds because, at the time of its launch, only Pluto had been found. The spacecraft's main job was to study Jupiter, and it sent useful information about the gas giant back to Earth. Pioneer 10's path and long life made it possible for it to go far beyond the orbits of the known planets. It went just past the Kuiper Belt and helped us learn more about the farthest reaches of the solar system. This was also the reason why more teams could be sent to explore this far away and interesting area. Later trips like Voyager 2 and Cassini helped us learn a lot more about the outer solar system. Voyager 2's famous trip to Neptune's moon Triton in 1989 and Cassini's study of Saturn's moon Phoebe in 2004 both gave us important information about these heavenly bodies. Scientists think that some of these moons came from the Kuiper Belt and were pulled in by the gravity of their parent planets. This really did happen, even though most people don't know it's possible. It was only the beginning. There was still a lot of information to be found in this area. In 2015, the New Horizons probe made history when it flew by Pluto for the first time. New Horizons took 4 pictures of an object in the Kuiper Belt called 1994 JR1 while it was on its journey. From 170 million miles away, this 90-mile-wide object was seen, giving scientists important information about the makeup and traits of Kuiper Belt objects. In 2014, the Hubble Space Telescope made a big discovery: 3 KBOs that were being thought of as possible targets for NASA's New Horizons journey to Pluto. The telescope also found two small cold worlds in the Kuiper Belt, which is at the edge of the solar system. This information, based on pictures taken on June 24th of the same year, led NASA to approve a wider search for Kuiper Belt objects. The main goal of this more intense search was to find an object that NASA's New Horizons probe could look at closely after its flyby of Pluto. The two objects found during this search are about 4 billion miles away from Earth and are currently named 1110113Y and 072009F. Hubble has been studying the Kuiper Belt since 2003, when it took two pictures of an object in the belt called 2000 FV53 12 hours apart. This particular object was first found in Hawaii in March 2000, and it was very important for guiding Hubble's studies. Hubble has found 3 new Kepler belt objects. They are very dim, up to 100 times fainter than the 2000 FV53 that was already known. Astronomers have to use computer research to find them because they are so faint that we can't see them with the naked eye. One of these things was tracked by Hubble's high-tech survey camera on January 26, 2003. This made it clear that we were dealing with a very large object. Things got really interesting when the James Webb Space Telescope joined the mix. Because of how advanced it is, it gives us new ways to observe and analyze things. The James Webb Space Telescope is a cutting-edge space telescope that is great for studying the universe, even places like the Kuiper Belt. Why? Because it works with light. Infrared energy is given off by everything that is warmer than absolute zero. The temperature of the thing affects how strong this radiation is and where it goes. Since it is very cold in the Kuiper Belt, the infrared radiation that comes out of it has longer wavelengths. This makes it easy for this telescope to learn more about it. It is possible for different materials to have different infrared fingerprints. Scientists study the specific wavelengths of infrared energy that an object in the Kuiper Belt sends out or absorbs when they look at it with infrared light. The object's composition can be figured out from these spectral traits. Astronomers can tell what kinds of chemicals, ices, and rocks are on the surface of a Kuiper Belt object by looking at its infrared spectrum. Water ice, methane, ammonia, and other molecules, for instance, have unique infrared fingerprints. Scientists can now figure out what the object is made of without having to rely on studies made with visible light. Not that. Also, infrared light is better at getting through dust and gas than visible light. Infrared studies give us a better look at space objects in places like the Kuiper Belt that may have dusty environments or thin atmospheres. This feature is especially helpful for studying the surfaces and characteristics of objects in the Kuiper Belt because it lessens the effect of interference and obscuration from the atmosphere. There are tens of thousands of these icy things at the edge of the solar system. They are really the oldest pieces of the solar system that still exist. Observations in the infrared range are great for studying things that are cooler, like those outside of our solar system. Observations using visible light might not give us enough information about these cold things, but their infrared emissions do. These emissions show us details about how hot they are. But that doesn't mean the JWST isn't also looking at it. The James Webb Space Telescope's large main mirror is an important part that makes it much better at making observations. The mirror of a telescope's main job is to gather and focus light from things in space. In the case of the JWST, its 21-foot diameter screen has a lot of surface area that can collect and focus light. The telescope can now pick up fainter signs from faraway objects thanks to its increased light-gathering power. This makes it especially useful for studying the Kuiper Belt, where many objects may be dim or far away. We have both here. It's also hard to see because the area is constantly giving off sun dust. Strong eyes are recommended. The telescope can also make pictures that are clear and sharp because of the size of the mirror. The JWST can see more fine features in the structures and surfaces of Kuiper Belt objects because it has a bigger mirror that lets it do so. This is necessary to get accurate and clear information about these faraway things. Because of how important this finding is, you need all the accurate information you can get. Having something like this on board is very helpful. The JWST's big mirror makes it perfect for looking at targets that are so far away. This lets scientists learn more about the composition, properties, and motion of Kuiper Belt objects. On top of that, the telescope has a sun shield that keeps the sun's heat and light off of its sensitive sensors. This sun shield is very important for keeping the telescope's working temperature low, which is needed for good infrared views, and it also blocks the sun's radiation. After hearing all of this, you might be thinking that it sounds like a really big telescope, but that's not the case. These were made to be the strongest ones we'd ever used. It has a high-tech set of scientific instruments, each one built to make specific observations and analyses. These high-tech add-ons make it easier to study things in space with the telescope, no matter how far away they are from Earth. One of the most important tools on board is NIRCam, which is made to take high-resolution pictures in the near-infrared range. Astronomers can see the faintest objects in the sky, even those in the Kuiper Belt, because it has a wide range of wavelengths. Because it can pick up infrared light, NIRCam is great for studying the thermal emissions and surface features of faraway things. Along with that is NIRSpec, a spectrograph that works best with the near-infrared range. Astronomers can study the light from things in space by breaking it up into its individual wavelengths. This feature is very important for understanding the makeup, temperature, and atmospheric features of objects in the Kuiper Belt. Spectroscopy tells us a lot about the chemicals that make up these faraway things. It works by itself, though. The MIRI telescope works in the mid-infrared range and can take both pictures and spectra. MIRI's ability to pick up mid-infrared radiation adds to what other tools have seen, giving us a full picture of objects in the Kuiper Belt. Also, there is the slitless spectrograph and the near-infrared imager. It has many uses, such as finely guiding the camera and imaging and spectroscopy in the near-infrared range. The fine guidance sensor helps keep the telescope pointed precisely, which makes sure that views are correct. NIRIS makes it easier for JWST to take clear pictures and measurements in the near-infrared range. All of these things work together to make the James Webb Space Telescope able to take the sharpest pictures of places like the Kuiper Belt. These pictures give us more information about things we had only seen in vague, blurry pictures before. One of the most famous things we've ever seen in the Kuiper Belt is Arakoth, a word that means sky in the Powhatan Algonquian language. The length is about 22 miles and the width is about 12 miles. It has an interesting look thanks in part to its long shape. The shape of Arakoth is a contact binary with two lobes that are 13 miles long and 9 miles wide. Along their main directions, these lobes meet, making a unique binary shape. The path that Arakoth takes around the Sun has a time of about 298 years. However, even though it seems a bit off compared to other spherical objects in space, its orbital inclination and eccentricity are both very low, which means that its path is safe and easy to predict. This is one of the oldest things ever found in the Kuiper Belt. The James Webb Telescope has already given us a lot of information about things that other projects have found, so it's only a matter of time before we learn even more. Can you think of anything else that might be in there? Write your answer in the box below.